I think eventually you'll just decide to memorize tangent too, but I'm going to show you how to do it if you don't want to memorize it. So today what we're going to do is we're going to put things on the unit circle that you actually already know, but we haven't incorporated that into the unit circle yet. For example, you know where 90 degrees is, right? And hopefully you know what 90 degrees is in radians too. I think you do. I think you know where 180 is, and I think you know what that is in radians. I think you know where 270 is. I think you know what that is in radians. And 360, I think you know that too. But we didn't put that on the circle yet, right? So in terms of the circle, you know this part, right? You know that if you were to fill in this circle, or at least you're working on knowing this part, right? This is 30, which is the same thing as pi over 6. This is 45, which is the same thing as pi over 4.
Can we get a new toolkit?
No, it's the same one. And then this is 60, which is the same thing as pi over 3. Those angles are new to this unit. And those angles each have their own coordinate point. So a rule to memorize that coordinate point is that all of those coordinate points have a denominator of 2.
What page of the toolkit?
This is page 7. All right? And the numerators from the inside is 3, 2, 1. And from the outside, it's 1, 2, 3. Each numerator gets a square root except for 1 because the square root of 1 is just 1. So I'm going to give the 3's and 2's square roots. Everything that I just did in blue is what we've been doing for the past 2 days in class. Practicing memorizing that and then using those things to find answers. What we're going to add today is something that you already know. This angle right here at the start is 0 degrees, which is the same thing as 360 degrees, right? It's where you start or it's where you finish, right? So I either start here and I don't go anywhere, or I've done a full circle and now I'm at 360. All right, and in radians, that's 0 and 2 pi. 0 degrees is 0 radians. 360 is 2 pi. I think you know that already. All right, and then when I go up here, I'm at 90 degrees. Does anybody remember what 90 degrees is in radians? What is it? Yes, 0.5 pi, or pi over 2. Same thing. I don't care if you call it 0.5 pi or pi over 2. All right, so I think you already know that part, right? And then over here, we're going 90 more. This is 180. And 180 is the same thing as, every time we're doing our rules, we take 180 out and we put pi in. So this is pi. And then we go another 90. And so this is 270. Anybody remember what 270 is?
1.5.
1.5, which is 3 pi over 2, or if you want to call it 1.5 pi, that's fine. All right, so 3 pi over 2, and then we're back at the start. All of that stuff in red, we've been filling out all units so far. But what we haven't been filling out is, well, what's the coordinate point at those places? So think about this. This is my coordinate point. What is the y value at that coordinate point? 0, right? I'm on the x-axis. I didn't go up at all. So the y value is 0. The x value is the radius of the circle. And it's called a unit circle because the radius is 1 unit. So that's 1. All right, so it's 0 because this point is not going up or down. It's on the axis. So the y value is 0. It's 1 because I'm going over the radius of the circle, and a unit circle has a radius of 1. So that's why it's 1. So let's think about what this point is.
1, 1.
Close. 0, 1. I'm not moving anywhere. I'm on the y-axis, which means my x value is 0, right? But my y value is the radius of the circle. So this is 0, 1. So what do we think this point is?
-1, 2.
-1, 0. I'm going to the left, the radius, So radius is 1, but it's on the left. So the x value is negative, and the y value is 0. And then what about this point? I'm going down the radius, 0, negative 1. Alright, so on Wednesday we were answering questions like this using quadrant 1, same type of question, but now we're using like the red points. So when it says find the sine of 0, I have to think about, well, what does sine mean? Sine is y values. So what this question is asking is, what is the y value at 0 degrees? So I go to 0 degrees and I look at the coordinate point. The y value at 0 degrees is 0. Cosine of 90 is basically saying what is the x value, because cosine is x, what is the x value at 90 degrees? So I go to 90 degrees. There's my coordinate point. And the x value is 0. So the cosine of 90 is 0. You guys following what I'm doing here? So what's the cosine of pi? Negative 1. Cosine is x, so this is asking me what's the x value at pi. So I find pi, and the x value is negative 1. So the cosine of pi is negative 1.
I'm lost at 48.
48.
Why is that 0 if it's 90? If it's up high.
So 90 degrees is right here. Yes?
Yeah.
Here's the coordinate point.
Yeah.
Cosine's the x value, sine is the y value. I'm asking you the cosine. If I asked you the sine, I would say 1.
I was mixed up.
Got it? So then cosine of 3 pi over 2, I'm going to find 3 pi over 2. Because it's cosine, I want the x value. If it was sine, I would want the y value. So cosine of 3 pi over 2 is 0. Are you okay with that? Are you sure? I couldn't have like cosine of 150 end up being one of these. Because these are not quadrants, right? Like I'm not falling in quadrant 2 where I can use a quadrant rule to get them. These are on the edges. So your answers are just going to be 1 or 0. And then you're just going to look at the unit circle. Let's try like another one with this. What if I said, and you don't have to write it down, but what if I said find the secant theta at pi over 2? What would I do? Secant goes with what?
Cosine.
Cosine. So I'm asking you first to find the cosine of pi over 2, right? So what's the cosine of pi over 2?
0.
Yeah. All right. And then I'd want to flip it, right? Yes?
Yeah.
How do I make that a fraction? How can I make 0 become a fraction? What could I make its denominator?
A 1.
1. So what happens when I flip that?
It's just an error.
It becomes an error. 1 over 0. If you had a calculator and you typed 1 over 0 in your calculator would tell you that that doesn't work. You're going to get an error. I can't divide by 0. Okay? So the secant of theta does not exist. Or you could write error, right? Like if I flip that fraction, 1 over 0 is an error. But the reciprocal functions work here, right? You just put them over 1 and then flip them. If I got like 1 over 1 and I flipped it, it would still be 1 over 1. So sometimes it works. It's not errors for all of them. Why not? All right. So last thing I want to do
Just
with
write
you,
error?
last thing I want to do, yeah, you could just write error.
Okay.
Last thing I want to do is solve equations with you, but using the edges. All right? So this is really similar to what we did yesterday. Those of you that were with me in the back, the process is the same, right? We want to get the trig function alone. So if I were to solve 51 here, I would subtract 5 and I would get sine of theta equals 1. Here's where it gets confusing, but easier, I think. Sine of theta equals 1 doesn't have a reference angle, right? Let's look at the completed unit circle in the back. If I went to this completed circle in the back, and I looked in quadrant 1 for when y, because its sine is 1, it's not anywhere. That's because sine of 1 is on an edge. And if it's on an edge, then it's not in a quadrant. So you can't apply quadrant rules to something that doesn't fall in a quadrant. Okay? So there's no reference angle for this. All you're going to do is look directly at your circle and pick the answers. You don't have to find a reference angle. You don't have to apply quadrant rules. Sometimes there's 2 answers, sometimes there's 1. But you don't have to do all the stuff that we did here, where it was like, okay, I found the reference angle, I did all students take Calc, and I applied it. This is on the edge, I don't do that, all right? So where is sine 1? So where is the y value? 1.
0.55.
And now this one is 0 to 360, so I want the degree of that point. You said pi over 2, right? So 90 degrees. These are a lot easier than the ones that we did yesterday, but what's hard is, are you going to recognize when you have to do the work versus when you don't? How do I know I have to do the work? It's when I get the trig function alone and I get a root 3 over 2, a root 2 over 2, or a 1/2, right? That means that this is something happening in quadrant 1, and so I need a reference angle, and then I need to use multiple rules. If it's something that when you get the trig function alone is a 0 or a 1 because it lands on the edges, you don't have to do the work. You're just giving the answer. So you're going to have to start to recognize when you do these.
Quick question. How do you know if you're not doing the work or not? Do you have to check because like what you have for this?
Is this like the only way you just like get into that when you have y is 1 or like
Yeah, 1 or 0 is really what you're going to end up with. Right, if I do the trig function and I get it alone, and I get on the other side a 1/2, a negative 1/2, a root 2 over 2, a negative root 2 over 2, a root 3 or a negative root 3 over 3, any of the variations of the 3 coordinates that happen in quadrant 1, I got to do a lot of work.
so you can either x or y value is -1 or 0.
Or 0, you don't have to do any work. You're looking directly at your circle. Yeah. So let's look at this one. So if I were to solve this, if I were to get cosine, like looking at it right now, I don't know if I'm going to have to do it all. You don't know it like originally. You have to get the cosine alone. So I would subtract 3. Divide by 2. And I end up with 0. 0 is not a value in quadrant 1, which means I can't use my reference angles. My reference angles are 30, 45, and 60. This is not going to apply to any of my reference angles. And that's because it's a corner point. Corner points do their own thing. So all I have to do is just look for this answer. And since it's x, I have to find where is x 0. So look on the edges at your coordinate points. Where is x 0? In degrees. X is 1, y is 0. X is 0 here at 90. X is negative 1, y is 0, x is not 0 there. X is 0, y is negative 1. So it's actually x, the x value is 0 at 2 places. It's 0 at 90 and at 270. So this one has 2 answers, 90, 270. Sine of theta is 0. So sine's already alone. When sine is alone, if you don't have a 1/2, a root 3 over 2, or a root 2 over 2, you don't have a reference angle. So this tells me that I need to use the corner points. And sine is y, so I'm looking for where y is 0. And that's going to happen on the edges, right? Having a y value of 0 means you're on the x-axis. So where on the unit circle do we have points on the x-axis in degrees? 180. And I'm going to write like 0/360. They're the same angle. I'm going to write both. If you wrote just 360, it's not the end of the world. But they technically are both on the unit circle, right? 0 and 360 are in the same spot, though. You okay so far? All right, well, what I do for 54? I divide 8, right? So cosine theta equals -1. Sometimes I'd be like, okay, where's cosine negative? Cosine's negative in 2 and 3. This is not one of the cases where I want to do that, though, because this is not one of my quadrant 1 points. If this was cosine theta equals -1/2, I'm going to pick quadrants, I'm going to find reference angles, I'm going to use rules. This is an edge point. For edge points, you're just looking. Where is x -1? And this is degrees because the directions say 0 to 360. So where's x -1? 180. In my opinion, easier. You don't have to do any work. You just find them. And the corner points are the ones you already know. We've been using them all unit. We're just adding the coordinates to it. You do the same thing in radians. So the next direction say 0 to 2 pi. And so instead of using 90 degrees, I'll use pi over 2. Instead of using 180 degrees, I'll use pi. So if I want to get my trig function alone for 55, I would subtract 7. And that's 1. And I would divide by -1 to get rid of that negative symbol. Cosine of theta equals -1. That's not a quadrant 1 reference. Quadrant 1 references are the ones with the fractions. That's not a fraction. So I'm just looking for where, and sine is y. And I'll pick the radian of that. So y is -1 at 3 pi over 2, or some of you call it 1.5 pi. That's fine too. The only difference is my solution's radians rather than degrees, and that's based on the directions. So if we divide by 7, so where does x equal 1? 0, 360 is where that x value is 1, but in radians, I'll call that 0 to pi. So here's what you guys need to remember about the corner points. 0, 90, 180, 270, 360. Pi over 2, or 0.5 pi, 1 pi, 1.5 pi, which is 3 pi over 2, 2 pi. Coordinate point here, I'm going over 1 because it's a unit circle, but I'm not going up at all. I'm going up 1, which is a y value, but I'm not going over at all. I'm going left 1, which is -1, but I'm not going up at all. I'm going down 1, which is -1, but I'm not going left or right. So those are your edge points. When I get sine alone here, I end up with sine theta equals 0. So I'm looking for where y equals 0. It happens at the two sides there. And so then my answer is the angle at those two places. So I'll call 0 and 2 pi the same thing. And then pi. So you tell me, what's the answer to the last one? Cosine theta equals 0.
2 pi.
Cosine is 0, so x is 0, not at 2 pi. Y is 0.
Oh, wait.
Which coordinate points here have x values of 0?
0.5 pi and 1.5 pi.
Pi over 2 and 3 pi over 2.
So it's 2 answers?
2 answers. And sometimes it's not, because like the ones have 1 answer. Cosine is 1 at one place, but it's 0 at 2. So you have to just look at the coordinate points. Alright, so what I need you, like just a summary of the end of the week here is, I need you to know the difference between solving that problem and solving that problem. So when the number on the right-hand side is one of the numbers that are in quadrant 1, then you have to do a series of things, all right? So what I would do with this one, just a summary from what we did yesterday and some of us what we did today, I would say, okay, well that's positive. And so since it's positive and it's sine, I know my answers are gonna be here. And since it's 1/2, which is something that's in quadrant 1, I'd find my reference angle by looking for where y is 1/2. And I'm just looking at the backboard for this, but the y value is 1/2 at 30 degrees. You'll have one in front of you. But like looking at those coordinate points, the y value is at 30 degrees, and then I would do a 30-degree angle in these two places. Quadrant 1, it stays the same. And in quadrant 2, I do 180 minus. And so when you have something like 1/2 root 3 over 2 or root 2 over 2, you've got to do some work, and there's going to be 2 answers. When you have something like this, when I'm looking for y being 1, that's not happening at 30, 45, or 60, so I'm not going to do all this stuff. I'm just going to look directly at the circle. Where does y equal 1? Where does y equal 1? Who gives me degrees? Look at your circle. Anybody have it? Where's the y value 1? It's 90 degrees. You see the difference between the two? I need you to be able to know the difference between the two and do the difference, like actually do the math. So what's going to happen next week, Monday and Tuesday, is going to be treated like one day because it's 2 30-minute classes because we have keystones. So on Monday, I'm going to show you how to get the tangent. We haven't done any tangents, right? Cosines x, sines y, so what's tangent? You'll have to do math to get tangent. You're not going to like it. Just pre-warning, all right? So I'll show you how to get the tangents on Monday. We'll practice with the tangents on Tuesday. So basically like one class. And then Wednesday will be quiz review. And then Thursday, even though it's a keystone day, I have you the long block. So Thursday will be the quiz and we'll have the long block. I'll tell you this next week as well, but Thursday we'll have a lunch. Okay, because your lunch is based on your 4th block teacher that day. So you'll have me that day. So on Thursday we'll do that. I don't have any Delta math for this unit, so there's no homework or anything. All right? Like which day is your lunch? So Monday, Tuesday, you have your regular block for lunch.
So Monday, Tuesday is still normal?
It's normal in terms of your lunch block. I think Tuesday, the order of your classes is different, but your 4th block class is the same. Like it's still the long block. On Wednesday, your long block is based on your block 5 class. So whoever